Hey there, Algebras. Here is your last video lesson. I'm excited to see you in school next week. Please make sure that you are keeping up with the videos. We should be on lesson 13. This is our last lesson of this unit. Next comes a review and then a test. So plan on your test on Unit 5 to be next Thursday, and that's going to be February 6th. So we can plan on having that together. All right, so today's lesson is, of course, about a system, but instead of having a system of equations, we have a system of inequalities, is where I have two or more inequalities on the same coordinate plane. So going back to the meaning of these words, system represents two or more, and they're inequalities. Now, the interesting thing is the only way to solve these systems, when I'm looking for solutions, the only way to solve these systems is by graphing. So in order to get a clear picture of our answers, we have to graph to solve. And then what it's going to be, our solution, is going to be the area that is common to both inequalities. And this sentence will make more sense to you once you see what the solutions look like. Okay, so here's some reminders when we're graphing inequalities. And these are true whether we're graphing 1, 2, or 3. You always want to use the solid line if your inequality is allowed to be equal to. This solid line is represented by this line, which is a part of the equal sign. You want to use your dotted line if there's no line here, because this means this here is more like a boundary for where the solutions come up to but don't cross. This equal sign represents that it is allowed to be equal to, which means solutions also sit on that line. Okay, so you must also shade where all of the solutions are. And again, putting your equation into slope-intercept form is a super smart idea, because that allows you to see where your slope is, and that allows you to see where your intercept, your y-intercept, is. Of course, this is where we start the graph. That's our B for beginning. And our slope, remember, is going to be our rate of change. And that's where we do the counting. We do the rise over the run. So keep that in mind when you're graphing. You should be a good grapher by now. If you have been listening to and following along with the videos, you've had lots of chances to be a good grapher. All right. So when we talk about shading above or below the line, we can talk about if y is greater than or equal to. We can talk about shading below for less than or equal to. But I have to tell you, I'm not a big fan of this rule. Instead, I would rather that you do test points. And remember, 0, 0 is always our best test points, because it's easier for us to check for a true relationship. That's always my preference. You can't go wrong with using that test Okay, so our directions say solve these systems by graphing and then identify two solutions. And what we want to make sure that we remember is these solutions that we're identifying have to be true for both relationships that we're seeing here. Each of these inequalities is a relationship. When we graph them, I'm going to graph it as if it were an equation and then come back and look at my signs. Okay, so here we have y is bigger than negative 2x plus 2. Here's our b. You know what to do there, positive 2. Here's our slope, down 2 over 1, down 2 over 1. I do not see a line on my sign, therefore this has to be dotted. When I go to pick my test point, 0, 0, I'm going to go ahead and say, hey, is 0 bigger than negative 2 times 0 plus 2? Is 0 bigger than 2? No, that's not true. So I'm going to color the area, and instead of shading all the way in, we want to just kind of draw it lightly, because we're going to have a third area that we shade that's going to be true for both equations, and we don't want our drawing to be too messy. Okay, here's our second rule. Y is smaller than or equal to negative 1. Hey everybody, this is a hoy. I know it's a hoy because there's no x, just a y, which means it's a horizontal line at negative 1. I see a line here, so I'm going to draw a line here. When I look at all the values of y are smaller than negative 1, that means that this area here is going to be where the solutions for my blue equation are. So here's what I want you to think about. I've got 4 areas of my graph. I've got this area here where nothing is colored in. I've got this area here where just orange is colored in. I've got this area here where just blue is colored in. And then I've got this area here where both orange and blue are colored in. And guess what? That's going to be what I'm looking for. So what I recommend is taking a highlighter or doing something so that you can tell the difference between what is a solution to just the orange, just the blue, and both the orange and blue. This is what we want. So when I go to pick any 2 points that are in this area, I can go ahead and say, I don't know, these 2 are in that point or in that area. So I can say go over positive 1, 2, 3, 4, 5, and down negative 2. My other one is over positive 7, down 2. So this area here. Now again, I told you the only way. Okay, so now we'll go on to number 2. I can't graph these until I solve for y. So as soon as you look at this, a problem like this, you need to look at, oh, where are my y's? And as soon as you see that, you know, okay, I'm going to have to solve for y first and put it into slope-intercept form. So I'm going to subtract 2x from each side. And when I do that, I get all the values of y are greater than or equal to negative 2x minus 4. Once I solve for y, do you see this? Here's your slope. Do you see this? Here's your b. So I come down to 4. 1, 2, 3, 4. That's my beginning, my b. Oh, I'll do some purple. Here's my negative 4. And I fall 2, run 1. That's the slope of negative 2. Here's my fall 2, run 1. Now, see how I run out of room here? It's the same thing if I rise 2, go backwards 1, rise 2, go backwards 1. I go back to my equation and I see a line. So if I see a line in the sign, then I can draw my straight line. That means that it's allowed to be equal to. This line represents where the graph is allowed to be equal to. Okay, my second equation, I have to isolate y, so I'll go ahead and subtract x from each side. Negative 2y is smaller than the opposite of x plus 4. Hey, 4 is positive. That's why we have that plus sign. When I divide by negative 2, I'm going to switch my sign because you know, anytime you divide by a negative with inequalities, you reverse the relationship. All right, so my y is then going to be bigger than, and this negative cancel out, giving me with a positive 1/2 x minus 2. So when I go to graph this one, my intercept is at negative 2. Here it is. That's my b. That's my beginning, negative 2. And I rise at a rate of rise 1, run 2, rise 1, run 2, rise 1, run 2. When I look back at my problem, I see no line, so I'm not going to draw a line. No line, no line, no line. So that means dotted. So there's some real potential pitfalls in these problems. First of all, not switching your sign. Second of all, missing the dotted line. Okay, so now let's go back and find our test points. With our purple graph, if I test 0, 0, is 0 bigger than negative 2 times 0 minus 4? Is 0 bigger than or equal to negative 4? Yes, that's true. So for my purple graph, I'm going to draw on this side of the graph. Here's where all the answers are. This is where all the solutions are. I can use the same test point for my pink line. Is 0 bigger than 1/2 times 0 minus 2? Is 0 bigger than negative 2? Yes, it is. So what I'm going to do then is color on the same side of the graph as where 0. So again, we have 4 areas of the graph. Here's one where just the pink is true. Here's one where nothing's true. Here's one where just the purple is true. But what we're most interested in is this area in here where they are both true. So when I go ahead and I pick solutions that work, we love 0, 0. Remember, that was our test point, and that worked for both of them. So then anything else in this field is what we can say. So if I want to, I can say, I don't know, over 0 up 5. 1, 2, 3, 4, 5. That works too. All right, let's go on to the next page of your packet and look at our next graph. Again, we're going to need to solve for y. Here it is, tucked into standard form. And in order for us to graph, we need y equals mx plus b. So my first step, of course, is going to be to subtract 3x. So I have negative 6y, that's what's left here, is bigger than negative 3x minus 12. How about all those negatives? So we're going to subtract or divide by 6, change my sign, divide by negative 6, divide by negative 6. And I get positive y is smaller. See the sign change? The alligator was eating the y this way, and now it's switched that way. And this makes positive 1/2 x plus 2. So when I go to graph that, I have an intercept, my y-intercept. I start at 2. And then I'm going to go ahead and have a slope of 1/2. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. I'm going to go back to my equation. What kind of a line am I drawing? Because my graph is not allowed to be equal to, I'm going to be drawing a, yep, you got it, dotted line. Put my arrows as my endpoints. I can go ahead and do my test point and my coloring for this line. Go, how is 0 compared to 1/2 times 0 plus 2? Is 0 smaller than 2? Yes, it is. So, because it's true, I'm going to go ahead and color in that side of the line. This is where all the solutions are to this line. Alright, so we'll do our next one, solving for y. We'll go ahead and add x to each side. We're adding x because that's already negative. That property of equality will cancel it out, leaving me with negative 2y is greater than or equal to positive x minus 4. Isolate y. I'm going to divide everything by negative 2. Of course, that will switch my sign because it's negative. So y is going to be less than or equal to negative 1/2 x plus 2. So we'll go ahead, oh, check it out. Same intercept, but instead of going positive 1/2, like this slope, I'm now going to go rise 1 and go backwards 2. Rise 1 and backwards 2. Maybe fall 1, positive 2. Fall 1, positive 2. Either way, I get all of my solutions in a line. Go back to my equation. I see a line, which means I'm allowed to draw a line. I can use 0, 0 as a test point. How does 0 compare to negative 1/2 times 0 plus 2? This cancels out. 0 is smaller than or equal to positive 2. Yep, that's true. So when I go to color these solutions, everything under this line is a solution. So again, you've got your 4 areas. Blue is true, nothing's true, green is true, and then here's where blue and green are true. So our solutions include this line, but do not include this line because it's dotted. That's where we can find all of our answers. All right. When I want to find 2 solutions that are true, I love 0, 0, of course. And then we'll go ahead and tell over 0 down 6. 1, 2, 3, 4, 5, 6. That's a fine solution too, as it's inside of that colored area. All right, our next one. When I go to solve for y, I'm going to subtract 2x from each side. So positive y is bigger than negative 2x minus 2. Here's my minus 2, down 2. I look back, there's no line, so I'm going to dot. If I want to use 0, 0 as a test point, how does 0 compare to negative 2x times 0 minus 2? Is 0 bigger than negative 2? Yes, it is. So this side of my red line has all of my solutions. All right, next up, we'll go ahead and solve for y by subtracting 6x from each side. So 3y is smaller than negative 6x plus 12. When I go ahead and I divide by positive 3, there's no need to switch my sign here because this is positive. So y is still smaller than negative 2x plus 4. So here's my b. 1, 2, 3, 4. And my slope is negative 2, down 2 over 1, down 2 over 1. down 2 over 1, down 2 over 1. No line, which means that my graph is also dotted. So this is interesting, and my picture doesn't show it, but when I go back and look, check it out. Do you see this slope is -2? Do you see this slope is -2? So my graph was a little bit off, but these lines should actually be more along the parallel side. Hey, how did I know that these lines are parallel? I took a look at the slope, and what did the slope tell me? Yeah, guess what the slope told me? That they had the same rate of change. Both of these equations were falling at a rate of -2. So let's try 0, 0 as a test point for my blue equation. Hey, is 0 smaller than -2 times 0 plus 4? Is 0 smaller than 4? Yes, it is. So guess what? The blue area is everything this way. So guess where our solutions are? This whole area in between the lines is the area that is bigger than the red and smaller than the blue. So this area is just blue is true. See these blue lines? They can come out further. See these red lines? They can come out further this way. But guess what? The only area where everything is true is that middle area. Kind of cool. All right, so when we pick solutions, of course, we love 0, 0. He worked. And anything else inside this band, I think 1, 1 also works. All right. It says you may use Desmos for the following and select the region on the graph that represents the solutions to the system. So go ahead, don't be lazy, fire up that Desmos. Okay, so here we are with Desmos. We have 3x minus 6y. To get my symbols, I come down here and I'm saying, okay, it's greater than -12. There's that graph. I'll have my second line. And I love this. Desmos even shows you it's dotted. So that's great. It takes care of that work for you. -x minus 2y is going to be greater than or equal to. So we'll go ahead and add that symbol, -4. So you can see Desmos is awesome. It uses a different color. So on your answer sheet, this is sector 1, where nothing's true. Sector 2, where only the red is true. Sector 4, where only the blue is true. So guess what your answer is? Number 3, where just that one's true. All right, circle the two inequalities that represent the system graphed below. Here's what's interesting. We have 6 different choices of equations. Let's start with this one. For this one, I see a solid line, so I know it's not going to be this one, or this one, or this one. So we're just going to look at where my line is solid. I notice for this one I have an intercept of -1. So guess what? This isn't going to be true, and this isn't going to be true. So for my red line here, this is going to be true. If I wanted to, I can substitute 0, 0 in and make sure it's shaded correctly. Is 0 bigger than 0 minus 1? No. So 0, 0 is not, so I'm double sure that that's the right answer. Okay, let's take a look at my blue dotted line. So my blue dotted line is going to be one of these ones. I have an intercept of +2. So guess what? Nope, nope, yup. And I have a negative slope, yup. And all my y values are greater than if I put 0, 0 in, it should not work. Is 0 bigger than negative 2 times 0 plus 2? No, 0 is not bigger than 2. So therefore, yep, I'm sure that's the right answer. All right. Drag the answers to the correct boxes. Create a system of two inequalities that could be represented by this graph. All right. So first of all, we've got some cleaning up to do. Well, no, this is the slope. So I have to compare my line that has a intercept, here's my B, of negative 3, and a slope of negative 4/3. So that would be rise, 1, 2, 3, 4, run, 1, 2, 3. So I know that this dotted line represents this first equation. So here's my dotted line, which means my sign is only going to be greater than or equal to, or greater than or less than, not equal to. So when I look here at shading above, so I'm going to guess that all my y's are bigger than. So when I make that guess, my first step is to do a test point. Should 0, 0 work? No. So if y is bigger than negative 4/3 x minus 3, is 0 bigger than negative 4/3 times 0 minus 3? Is 0 bigger than negative 3? No. Because it doesn't work, I know I did a good job choosing. All right, let's take a look at our second line. In this red line, of course, I see my line. So that means I know that this is allowed to be equal to. I draw my line there. Positive 3 is my intercept. 2/3 is my slope. Rise 2, run 3. So far, so good. Now what I'm talking about is I want to make sure that I'm talking about this area that's above. So again, I'm going to say y should be bigger than. Here's y being bigger. But of course, you know what I'm going to do. I'm going to check about whether or not 0, 0 works. Should it work? No. So this zeroes out. Is 3 smaller than or equal to 0? No. So I know that I'm good with how my signs work out. All right, check out the next one. For which system of inequalities is 0, 1 a solution? So what I'm looking for here is just a really long task of plugging and chugging. As soon as I find one that doesn't work, I'm going to move on from that whole system. So I'm going to start with these equations that are much simpler. Okay, so I have 0 plus 1 is greater than or equal to 1. That's okay there. 0 plus 1 is greater than or equal to 1. 0 plus 1 is smaller than 1? No. So I can cross C out, and I can cross D out. Okay, so now I'm going to take my solution and plug it in here. 4 times 0 plus 8 times 1 is smaller than or equal to 8. Is 8 smaller than or equal to 8? Yes. So far, so good. 4 times 0 plus 8 times 1 is smaller than 8. Is that true? Because, of course, that zeroes out. Is 8 smaller than 8? No. So then the answer here is going to be A. All right, number 8. Shade in the box to choose each point you want to select. You must select all the correct points. Here's my system of inequalities. From the given points, select each point that is a solution. All right, so we'll start with this easier equation here. And we'll say, is 0 smaller than or equal to negative 2? Ooh, this is 3. Is 3 smaller than or equal to negative 2 times 0 plus 1? Is 3 smaller than 1? No. All right, let's try this one. Is negative 3 smaller than or equal to negative 2 times 0 plus 1? Yes. So far this one's true for this one. Now I have to check this one. When I check my second equation, is negative 3 minus 2 times 0 smaller than 6? Is negative 3 smaller than 6? Yes. So because it's got a blue and a green and a red check, this is a solution. All right, let's try this one. Positive 2, 5. So when I put this into my first equation, is 5 smaller than or equal to negative 2 times 2 plus 1? Is 5 smaller than or equal to negative 4 plus 1? Is 5 smaller than or equal to negative 3? No. So because it doesn't work for blue, it's not a solution to the system. As soon as I get one no, that's it, we're done. All right, let's check this next point. Is negative 4 smaller than or equal to negative 2 times negative 1 plus 1? Is negative 4 smaller than or equal to positive 2 plus 1? Is negative 4 smaller than or equal to 3? Yes, that's true. So now I have to test this point in this equation. Is negative 4 minus 2 times negative 1 smaller than 6? Is negative 4 minus, this is negative 2 smaller than 6, so that's plus a positive. Is negative 2 smaller than 6? Yes, it is. So we're going to say yes to this one and yes to this one. Now, if that was too much work for you, guess what you can do? Go to Desmos, type in both of these, and see which of these points is in that shaded area. Okay, here it is typed into Desmos. And when I look at over 0 up 3, I see that over 0 up 3 is in the blue but not the red. So no, that's not a solution. When I type in over 0 down 3, and I can make this a little bit smaller if I want to, because now I can see over 0 down 3, yes, that is inside of that double shaded area. Over 2 and up 5, that's in this one, but not this one. When we type in over negative 1 and down 4, sure enough. So by typing both of these equations as is into Desmos, we get a quick and easy picture. Don't forget, you have Desmos available to you for the entire SOL and for this next test you're taking. All right, so that's it for this. Make sure that you finish today's work and make sure that you do homework 14. When you come to class next week, your entire packet should be complete.